So Redis has a very interesting feature called pipelining. A typical way to fire commands to Redis server is that first your client connects to the Redis server, right? It's a TCP connection. Then your client fires the command, server computes the response. It basically does the needful and it sends back the response, right? So first you do set k comma b, then your Redis responds okay. Then your client sends get k and then it sends v. Right? So here, if I'm just setting a particular key and then getting the value for that particular key, I'm doing a lot of round trips because a lot of packets needs to be sent across the network from your client to your server, from your server response back to client, then the second request, then the response to that. So here, if it's within the same machine, you would not see a difference because it's just local connection, it's just local host. But as it goes in an infrastructure over the internet, maybe this round trip times become extremely critical, right? Because this is the major, basically this is the major cost that would be involved when your client is firing a lot of requests to Redis and your server is responding back. So a lot of time goes into this round trip. So can we optimize this? This is what pipelining actually does. So the idea of pipelining is pretty simple. That hey, instead of just sending one command over the TCP network, what if I send multiple commands? Multiple commands in one request. So for example, if I am firing 3 commands, right? So instead of sending first command, then getting the response, then fire second command, then get a response, then fire third command, then get a response. Instead of that, what if I fire 3 commands back to back in one request? So in one round trip, I'm able to send command 1, command 2 and command 3. And your server can independently execute command 1, then command 2, then command 3, and then in one time response, it sends me back the result. So for example, if I do ping, set kv and get k, in response I'll get pong, okay and v. Here one key thing to note, it is not a transaction. It is just command pipelining in which you are multiplexing a lot of command in one request, sending it to the server. Server will execute them one after another and it would send you n responses. So if you send n commands, you would be getting n responses out of it. So it is just about clubbing the request. Right? It is not about transaction at all, right? So your server is independently executing those those n commands that you pipeline. It would compute n responses and it would send you back n responses multiplexed in one response, right? So overall, you just do one get or one request and one response. In that one request, you are multiplexing a lot of commands, right? So this is the idea of pipelining. Now, with pipelining, you'd say, why do we want to do that? But before we do that, if you think about it, when your client is sending multiple requests to the server, now your server, instead of evaluating one and then immediately sending back the response, what it has to do is it has to buffer, because your server can only send one response. In that one response, it has to send everything. Right? So in request, if I send 3 commands, in response, I have to send 3 responses, right? So which means that your server has to buffer the responses. So if I'm sending 3 commands, then your server is evaluating one, output of which is buffered in memory, then evaluates second, output is buffered in the memory, evaluates third, output is buffered in the memory. And then once everything is evaluated, it is sending back 3 responses. So here what would happen is it would lead to a higher memory consumption. So if you're doing a lot of pipelining, agreed, you'll get great throughput, but it would have an impact on memory consumption. So you have to be wary of that fact, right? But obviously, pipelining helps you improve throughput because now the number of operations that you can run are much larger. Otherwise, a lot of time of your Redis server goes into waiting for getting the request and then sending the response. So a lot of time goes into that because system calls are blocking. So overall commands per second that you are executing is substantially higher when you use pipelining, right? So for Redis, why so? Because for Redis, because all the operations that you are doing, they're in memory, which means that computing them would not take much time. When it receives a command, for it execution literally takes microseconds, if not nanoseconds, right? It would be much faster. A lot of time of Redis server also goes into making the network call, sending back the response or receiving the response from that, right? Which is where your power of pipelining comes in. With pipelining, your Redis has to do fewer context switch from your in-memory processing than to network IO. Because now imagine if you pipeline 100 commands, right? So here, instead of like get one command, compute it, or basically make the necessary changes and send it as a response. So IO, you are doing network IO, then doing some CPU processing or some basically memory input output, and then you are responding back. And then again, the cycle will come back for hundreds of requests. Instead, if you are pipelining hundreds of requests in one request, it gets it. It can quickly fire 100. It can quickly evaluate those 100 commands without having to context switch to network IO and then immediately send back. This is the power. This is why it betters the throughput, right? Now that we understand what pipelining is, let's quickly take a look at it. How do we implement it in our implementation? The implementation seems pretty straightforward, but just few hunches here and there that would come our way, right? But before we do that, it's always better to see how pipelining indeed works, right? So let me quickly do this where I'll show you, like always, top right is where our normal Redis server is running. And what I'm doing is I'll be putting in commands. I'll show you how basically commands are fired, how pipelining is done so that we know how to implement it, right? So here I'm connecting to normal Redis client, not here, but here bottom left is you can see Redis CLI. Redis CLI, and I'm doing -p port 637 because I'm connecting to normal Redis server. Now if I connect to that, now let me fire a command. So here I'm sending ping and in response I get pong, right? This is normal command that I'm sending. But with pipelining, what happens is you have to send multiple commands in one shot. So what we would do is we would be firing a simple netcat. Through netcat, we would be sending the request or the normal bytes to the server. So here how it would look like. So in pipelining, what we would do is we would be just doing this. So here what I'm doing is I'm doing a printf. It's a shell printf in which I'm passing command 1, command 2, command 3 piped with netcat localhost 6379. So 6379 is our normal Redis server, right? So here I'm literally putting command 1 after command 2 after command 3 and then sending this, encoding this in bytes and sending it as a request to 6379, right? This is what the pipelining is all about. So in one request, in one network packet, or not really network packet, but in one request, in one IO call, I'm sending this entire request in which it has multiple commands literal concatenated. If I fire this, I'll get some response because it is not proper. But let me do this, right? It sent a response, but it did not get any response because this was invalid. Let me put a proper command here. So if I do this, it would look something like this. So here, don't be scared of this. It's normal that we have always written the RESP protocol. It's the exact byte that we are sending. *1 implies it's an array. Remember when we send commands through Redis CLI, it is sent as an array of strings. So let's say if I'm sending ping, set k, v and get k, right? If I'm sending that, here you can see we are doing *1 /r/n $4 /r/n ping /r/n. This is your ping command that you are sending, right? It's a bulk string encoding, right? This is how we are sending ping command. Then the second command that we would send is set kv, right? So set kv is 3 element array. So your first thing becomes *3, right? Array of 3 elements /r/n $3 /r/n set /r/n. So set and then $1 /r/n k, then it's /r/n, then $1 /r/n v /r/n. This became your kv, right? Set kv. And then the third command is *2 /r/n $3 get /r/n $1 /r/n k /r/n, right? And I'm passing this to 6379. You see the response, right? So we passed in 3 commands back to back, right? So it's just one request that has went in, and now we are getting in one response, we are getting output of 3 commands, right? So here output of first command is perm, set k comma v is okay, and then what we are, and then when we fire the next request is get k, which means we are, because this is a normal network protocol, that is where you see $1 then v. It's basically $1/r/n v/r/n, and which is why it is printed like this, right? So we send 3 commands back to back, and in response we got 3 commands, or the output of those 3 commands, right? This is what pipelining is all about, and this is what we have to make changes in our code base to implement this, right? Okay. Now let's move to our code base, and this is what our code base actually looks like up until now. So what we would do is we would start somewhere. We would start, the fundamental thing is changing. Like earlier, we wrote a code such that it was accepting in one network IO one request, and then we were sending one response to that, right? Let's just quickly take a look at what would have changed. So I'm in my async_tcp file. And here if you look at, nothing has changed up until now, but here something has changed. So our function read command, which was reading one command, because our Redis CLI was sending one command and we're getting one response, right? That's what we implemented. That now changes to read commands, right? So we are accepting that same communication object, and instead of getting one command, I'm getting multiple commands. And in response, instead of passing one command, I'm passing multiple commands. That is the fundamental change we are doing. So first, let's take a look at read commands. So read command was written in sync_tcp file, the first ever implementation that we had. Now here, instead of sending one, we are sending many. So if you look at this, I've created a new type called Redis CMDS, which is just an array of star Redis command. So the normal Redis command that we had now changes to array of Redis star. So that's why I'm just naming it, right? It's just multiple commands that we are passing. The idea here is pretty simple. Earlier we used to do decode 1, right? Instead of just doing decode 1, what we are doing is we are continuously decoding it. The idea here is that we would want to accept multiple commands through that. So which means that like we just saw when we sent the request, we just got multiple commands back to back, literal concatenated. So earlier when we got a body, right? Earlier when we got the value from the Redis client or anywhere, we just parsed one object out of it. We never looked forward. Now we have to, right? So that is where what we are doing is we are literally iterating through this. So we are decoding, we get values, and values we are iterating through this, and each value would be, I'm converting it into array string that gives us token, and then I'm appending it and I'm creating normal Redis command out of it, which we already did. Right? We already created this, and now this to array string is doing nothing but accepting an array of interface and converting it into string. Nothing fancy here. Right? So the idea here is I'm decoding everything that I have. Like here, if I look at this, the main function decode now changes. Earlier decode function used to decode that one value, but now instead of returning an interface, it is returning a slice of interface. This function is that main thing that got changed. So now what we are doing is, the idea is pretty simple. Our decode function, instead of returning one object, it will be returning an array of objects, right? So for example, if I am passing one, because each command that we are sending from Redis CLI to this, each command that we are sending is an array of string, right? And we have multiple such, so it would be array of strings, right? But how do we get that? The idea here is pretty simple. So here I'm just creating values, like a decode can iterate through, instead of just decoding one value, we are iterating through multiple such concatenated values until the data ends. So here I'm creating values having some index, decode 1, and decode 1 returns object, the delta, like the number of bytes read, right? And error if any, right? Remember we used it during encoding and decoding, right? Third, fourth video, in which when we were understanding RESP, that same thing will be utilizing over here. Delta becomes our friend. So now what we are doing is, let's say I'm passing in 3 values back to back concatenated. So I'm reading first value, and then my delta would be the number of bytes that I've written over here. So I'll start from here, and then read the second value. Then I'll start from here, read the third value. So my decode function, instead of returning one object, it will be returning multiple objects, each decoded back to back, and value is appending over here. This is the main change that we are doing, right? So decode was returning one object. Now it is returning an array of objects. And then each object, if we are doing pipelining, this would be an array of strings, right? So that's the idea behind it. Okay. Now that we have sorted out our decode function, now instead of having one command, we are getting array of commands. And now this array of commands can now very well be sent for response. This is where I've read the commands, and in respond, we'll do that exact same thing. So respond, instead of accepting one Redis CMD, it is now accepting multiple Redis commands. Even if we pass one, it would be just array of strings. Right? So now we are doing this, and I'm passing it to eval and respond. Eval and respond, now instead of getting one Redis command, it is getting multiple Redis commands. Because it is getting multiple Redis commands, so instead of having direct switch case, we are putting it within the for loop. Right? So our main logic does not change. It's just that the way we were consuming the input, now it changes. Earlier we were just expecting one command, now we can have array of commands. Right? So now we are iterating through every single command, evaluating it the way we used to, but now instead of directly returning it, we are adding it to a buffer. So earlier the code that we wrote used to, in the evaluation, we used to pass IO read writer, and then used to write to it directly, right? But now instead of that, the eval functions that we have, they would be returning the response, they would be returning the output, and this would be added to the buffer, and at the end of this eval and respond, we would be sending it over the socket. That's the idea now. So the peripheral has changed, everything else has remained the same, right? So now let's just take a look at how set would work, right? So just taking example of, let me just go through all of them. So I've just created some helper constants that were there so that we don't have to re-implement it again and again and just copy, like just use this variable instead of writing this complex part and rewriting it every time, right? Now eval ping, instead of returning it used to return an error, but now it is just returning a slice of bytes, which is the actual response. So now in case there is an error, we are encoding the error and returning it over here. Otherwise, everything else remains the same, and output is bytes. Similarly for set error, we are encoding earlier we used to directly send error, but now we are encoding the error and sending it. Then we come over here, again encoding the error and sending it, encoding the error and sending it, encoding the error and sending it. But at the end, we are just creating this new object and returning response okay, right? So here instead of doing socket IO, we are just returning this slice of byte, which will then be sent over the socket by eval and respond, right? That's the idea. Similarly, all the changes have been made at every other level, right? Instead of returning error, we are returning encoded version of error, which is a slice of byte, encoded in RESP format like this. If it's an error, we are doing -%s/r/n that we all learned, right? That same thing we are doing over here. And for eval TTL also exact same thing. So the idea here is, instead of accepting, so now we are making our code generic enough that instead of just being restrictive, that we'll get one command and we have to compute and respond. What we are doing is we are accepting concatenated commands, understanding it, interpreting it, evaluating multiple commands and buffering the output and sending it back. So the eval and respond command that we have, this is where we are buffering all the output, because here we are doing buff.write, which will write to this buffer. The output of ping command will be written to this buffer. Then we are doing set, output of set command will be returned to this buffer. Then we are doing get, output of get will be returned to this buffer. And when we pass in this three command, evaluation is done, then we'll do this c.write buff.bytes, right? So the entire thing would be sent over the socket to my Redis client. Right? And this is how you would be implementing the pipelining logic. We have covered every single file that we altered. Everything is right here. Nothing has changed much. It's just that now we have made our code generic enough that we are supporting pipelining. Right? Initially, even when Redis was built, they never thought that they would have to do that. They also started something similar, except one command responded back, and then the new feature request came in where they have to make their code as generic as possible. And this is how you would be implementing pipelining. Right? We covered all the files that we had to. And this is how you implement pipelining. Let's quickly take a look at the implementation or on when we are doing it on our own server. Go run main.go. And now here I'm passing that exact same thing, but instead of passing it to 6379, I'm passing it to 7379. I get pong, I get plus pong, plus okay, which are simple string that in this response that we send, and then $1 v/r/n. Right? So we just implemented, we have just started supporting pipelining in our own Redis implementation. Right? Fascinating, isn't it? So start small and then eventually build complex features on top of it. Keep code as generic as possible. Right? For us to make this change, we didn't have to change a lot of stuff. It's only the input output part that we had to change because every other thing, every other function was encapsulated. Right? And this is how you should be structuring your code so that your life becomes simpler when ad hoc requirements come in. And that is it. That is it for this one. I hope you found it amusing. I hope you understood how pipelining, like what pipelining is, how it is useful and how useful it is rather, and how we implemented it in our own Redis implementation. Right? The idea would remain the same, keeping the code generic, accepting multiple concatenated commands, buffering the response and sending it in one shot. Right? Earlier we thought that we would be streaming the response, that would be much helpful, but not at all. Pipelining changed that flow. We had to keep, now we have to buffer the output and send it in one shot. Right? Great. That is it for this one. I hope you liked this. I hope you learned something interesting. I would really appreciate you to implement, I would really urge you to implement this. The source code of this, again, github.com/dicedb/dice. You can go through this particular commit to see how it is implemented. The name of the commit messages are self-explanatory. I would highly encourage you to check out till this commit and see the changes that we made. Right? So that is it for this one. I'll see you in the next one. Thanks, Atta.